So when we first started out doing your cityscapes and your aliens, if you wanted to have an image that looked like this is what you'd have to do. If you knew about variables at that time, that would be great. You could at least use the variables. If you didn't know about variables, then you would have to actually write in these specific numbers like 50, 100, 150, or however you want to increment them. So it's a lot of lines of code. Then we learned about the if statements that basically could say like, if we could start up here and then if we are less than this, run this code. And that would give us this shape in just a few lines of code, but it would animate out. So now what we're going to talk about is how to do the same thing, but have the code be completely there as an image and not animate out. So if you look on Blackboard, you can download these two processing sketches. One's called loop one if statement and the other one is loop one while statement. Run them both and then what's the difference? So they're almost the same, but the difference is that you saw in the one with the if statement that animates, it draws it out. And the one that is in the while statement is static. But look at them, they're almost exactly the same. They both have variables that are initialized and declared. They both have Boolean statements, right? They're the exact same. Here on my PowerPoint, I flipped the order, but that doesn't really matter. Maybe by the time actually I put this PowerPoint on Blackboard, I'll correct that. This order can go in either way, but they both have a shape and they're both taking their variables and increasing them. The difference is one says while and one says if. So the if statement, what it does is it starts at the top of the code. It's like, okay, I have these variables. When I find them, I'm going to put in these numbers. It starts, it puts in the size, it goes to the background, it finds this if statement. It looks to see if this Boolean statement's true. If so, it runs this code once, and then it goes back up. If the statement is still true, it runs the code again, and then it goes back up. If the statement's still true, it keeps going. It repeats. That's why it looks like it's animating. With the while statement, it starts up at the top, it puts in the size, it has the variables. I'll explain this in a second about why the variables are down here. And it looks into this code, it looks at the Boolean statement. If it's true, it runs everything in here until this Boolean statement's no longer true. So in the if statement, it goes all the way back up to the top. In the while statement, it stays within this while statement until it's finished. And so that's why it doesn't play, it doesn't give you the code until it's done. So that's why it looks like it is just static and not animated. So a new convention when you're working with the while statement, we're going to put our variables, we're initializing and declaring right above our while statement. This does not work if you tried to do this with your if statement. If I took my if statement and I moved my variables from the top down into the background, sorry, down into the draw, just like I have in my while statement, it wouldn't work. So just take a moment, pause, and try that. Take your variables in your if statement, move it down, and press play and see what you get. So what you should get is just one rectangle that stays up at 50. And that's, I just want to illustrate the difference because, again, the if statement, it starts from the top and it goes down to the bottom. It looks for what's in this statement. It plays the code that's in here, and then it goes back up to here. So what it's doing is it keeps resetting it back to 50. Where in the while, it doesn't go back, it doesn't go outside of the while statement until it's done. So it just keeps repeating them over and over again. I'm not really talking about the stuff that's inside yet, our statements, because it's exactly what we've been doing with our if statements. Okay, so here we have our syntax. We write while, our Boolean expressions. So remember, this is like the if you did your homework. We have our open curly bracket, closing curly bracket, and this is the reward. So exactly like the if statement. All right, so now let's try to build some. So if I want it, what I want to say here is I want to start with this rectangle at the top and I want it to draw all the way till we get to the bottom, okay? And let's say if I make my rectangle 10 high, it needs to jump down like by 20 or something like that so that I always have a space in between. Okay, so pause this video for a second and start out with your void setup, your void draw, and then in your void draw, initialize a variable. Ask yourself, what's moving? Is the X moving? Is the Y moving? Is the width moving? Is the height moving? Only one of those is moving. So you need one variable. Initialize and declare it so it's our first rectangle starts at the top. Then make your while statement and give a Boolean condition that would tell us when for this to stop, and then make your movement. So pause and then come back. Okay, so here's our answer. I have the only coordinate that's moving is the y, so I made that into a variable. And I'm saying while y is less than height, give me a shape. I'm using y, and I'm incrementing it. So it keeps going while it's less than height. So I'm just going to copy this code. Make a new sketch here. And let's say I want it to stop earlier. Let's say, so instead of saying while it's less than height, I'll say while it's less than 300. Now it stops earlier. If I wanted to start lower, I'm going to target my starting point of my y. So I'll have this start at 100 instead. So now my first rectangle starts down lower. And it continues until 300. That's this number here. Here's my rectangle. X is fixed. Y is the only thing that's variable. These two numbers are fixed. And I'm having it jump down by 20. If I wanted more space, I would increase this. And that would have each one start earlier, further down. Okay, so it's really just like the if statement. Let's do another one. So in this one, I want to target the diameter of the circle. So I'm going to start with a variable. I'm going to call it diam, and I'm going to have it equal width. So my first circle is the one that's outside here. Then I'm going to use the while loop to reduce the width of the diameter by 20. So while diam, so I'll let you work on that. And use the diam variable for the fill as well. So that's how you can get this gradient. Okay, so pause the video and then come back. So here we are. I made it a float. It doesn't have to be a float. Int diam equals width. So that's my first one, making a big circle. I'm saying while diam is greater than 0, and I put in my stroke and my fill. I also put it in for, I gave the variable diam. Have my ellipse. It starts in the middle, and I'm just worried about, or not worried about, but controlling the width and the height, so my diameter. So I use those variables, and then I have it subtract by 20. So again, let's put this into a sketch and analyze it. So if I started out with a big one and I made it get smaller. So let's just do it in the opposite way. What if I wanted it smaller, getting larger? So I would instead have it equal, start out at a small number, and say while it's less than my big number. I could say, I'm not going to say width because I would just want to make it noticeably different, 400. This all stays the same, but I would have to add onto it instead of subtracting because I'm going smaller to larger. And it's there, I just can't see it. So what do I need to do? I need to do, I'm going to do no fill. So we can see it. And there it is. Okay, so at this time I started out with my small one, and I said while it's less than my bigger number, keep adding on to it. let's try some with some other shapes. So besides just our circles here. Here's an example of create two variables this time. And this is something I do like about the while statements. You can have two different variables in your Boolean. Remember, it's a double and. So in this case, I made a variable for my x1 and my y1. And I'm saying while they're less than 500 or and less than 300. And then I just made a Bezier, which I know has 8 different coordinates. And I threw in my x1 and my y1, and then I put in some numbers. This was all just completely random. Didn't really spend a whole lot of time thinking about this, but this is what I'd like you to do is try now with a Bezier or some other different type of shape and see what you get. So now, I have some of my numbers are stable and some are variables. So what if, I just you could try kind of keep tweaking, or maybe this one, maybe I don't want this to be in the middle. Maybe I want this to be y1 plus 300. Don't really know what that'll give me. Maybe it'll be a disaster. Yeah, not as interesting as what I had before. Okay, so take a pause here, try with a different shape, such as a Bezier or triangle, but use two different variables this time. And then, so Bezier or triangle are good because you need to, so that all the points aren't on top of themselves, do this like x1 plus 100, y1 plus 150, just like you did when you were doing like your alien. We always had to keep adding out to it. So pause the video and try. So when you come back, I want you to do another practice, start a new sketch, and make another repetitive pattern out of a single shape that we've not already used using the while loop. And the last thing I want to cover in here is this has shown up already in a couple of videos, but the increment, the operators here. So sometimes you'll see this x plus plus, and just to point out that that is a shortcut for writing x equals x plus 1, or x minus minus is x equals minus 1. This one I don't use as much, but I just wanted to point these out in case you start seeing these in my code examples. So instead of writing x equals x plus 10, you could write x plus equals 10. Kind of another haiku. All right, so work on the while statements. Let me know if you have any questions on the while. In the next video, I'll talk about the for statements.